Today we're diving into this incredible, totally hidden journey that transforms a simple digital click into a physical action. We literally do it hundreds of times a day, right? But without a very specific, totally invisible piece of software called a device driver, your computer would be completely powerless to interact with the real world. So how exactly does a simple click on a screen force a mechanical arm to move or a printer to lay down ink? It honestly seems a bit like magic. We hit a button on a piece of glass and boom, across the room a machine wakes up and just does it. Well, today we're going to demystify the exact chain of software translations that makes this whole shebang possible. We'll see why for sure your computer desperately needs a dedicated translator to speak to the physical world.
All right, Section 1, the human hardware gap.
To really wrap our heads around how our clicks become physical reality, we first got to recognize the massive communication gap between us humans and cold, hard metal. I mean, we speak in ideas, images, and intent. Hardware? It speaks in electrical pulses, turning gears, and moving physical parts. It's like they're speaking two completely different languages. That's where the operating system steps in. It serves as this absolutely vital bridge and master coordinator, linking our high-level requests to all that intricate circuitry down below. If we look at the software hierarchy stack from top to bottom, we can actually map the exact distance a command travels. It starts at step 1, with us, the human users, interacting with step 2, application software, like your web browser or photo editor. But those apps can't just talk directly to the computer's chips. They have to pass the baton down to step 3, the operating system. The OS then relies on step 4, other system software, which is exactly where our crucial device drivers live, before finally hitting step 5, the physical hardware itself. It is a strict, continuous chain of command. Moving right along to Section 2, the master software layer. Before we trace a specific click, let's look closer at that crucial third layer, the OS. There's a wild variety of them running our devices. Take a single-user OS, for instance. These are designed for just one general user, usually found baked right into household appliances like a smart TV or a microwave. It just does its job for whoever pushes the button. But then compare that to a network OS. Those are vastly more complex. They require distinct private accounts, user authentication, and they manage shared stuff like network storage or office printers. But look, whether it's a basic single-user setup or a heavy-duty network OS, this software layer is the undisputed boss of the machine. Honestly, think of the OS as a really brilliant traffic cop. It handles memory allocation, giving 30% of your RAM over here, maybe 40% over there, and if it runs out, it expands into virtual memory on your hard drive. At the same time, it's managing sequential system resource queuing. Basically, it's constantly taking all these competing requests, a print job, rendering a video, saving a file, and placing them onto an orderly sequential conveyor belt. It brings order to the chaos, so your processor and peripherals don't just, get completely overwhelmed by everything trying to happen all at once. Okay, Section 3, the application ecosystem. Sitting just above the OS is the application ecosystem. This is where we actually spend our time creating digital intent. Take document engines, for example. You might just fire up basic word processing software to type up a quick letter or an essay, right? You're relying on simple text formatting and spell check. But if your intent is way more complex, you'd move over to desktop publishing. That kind of software is engineered strictly for complicated, highly structured page layouts. Think professional magazines and brochures that need really advanced positioning and layering. Now, what if our intent is visual instead of text-based? We'd work with a creative engine. And even here, the application fundamentally changes how the computer interprets our clicks. Take bitmap images. When you edit a photo like this, you are literally altering a strict grid-like arrangement of pixels. It's incredibly detailed, sure, but it loses quality if you scale it up. On the flip side, we have vector graphics. With vectors, your clicks are generating mathematically defined points and lines. You can scale a vector graphic infinitely, and I mean infinitely, without losing a single drop of quality. So the app translates your artistic intent into either a pixel grid or a mathematical formula, all getting ready to hand off to the OS. And in some highly specialized cases, our applications are specifically designed to bridge into the physical world through a continuous feedback loop. These control applications automate physical devices. First, the system gathers sensor input, like temperature or motion. Then, the software analyzes that input during the OS decision phase. And finally, it sends an output command to trigger an actuator. That could be turning on a heater or moving a robotic arm. Then it loops right back to monitor the new physical state. It's this beautiful, continuous conversation between software and physical reality. Which brings us to Section 4, translating intent to hardware. All right, main event time. Let's trace a click down that entire software ecosystem in action. Say a user is printing a cropped photo. It starts with a human clicking print on the mouse. The app prepares the file and hands it down to the operating system. The OS allocates the RAM and drops the data into a queue. But here is the absolute critical moment. The OS still cannot speak directly to the physical printer. See, the OS speaks in universal computer logic, but the printer? It only understands the precise mechanical movements of ink rollers and paper feeders. Enter system software, and specifically device drivers. This is the whole reason you can't just plug any random machine into your computer and expect it to magically work. Device drivers are software that translate the queued data from the operating system into specific mechanical code that the physical hardware can actually execute. Without them acting as dedicated translators, the physical hardware is completely blind. A printer driver takes the OS's generic printless image command and translates it into proprietary mechanical code. Move this roller here, fire this exact ink nozzle for 3 milliseconds, advance the page. Literally every single piece of hardware you attach, your mouse, a graphics card, your printer, needs its own specific driver.
Finally, Section 5, overcoming physical bottlenecks.
So, even with the perfect translation from the driver, we still face a massive physical challenge. Think about it. Computer processors operate vastly faster than physical gears, belts, and ink cartridges. If your blazing fast computer had to hold a direct connection to your low-speed printer, waiting for it to finish page by agonizing page, your entire system would freeze up. You wouldn't be able to do anything else. To prevent this, the OS uses a print spooler. It acts like a high-speed conveyor belt between the processing unit and the physical printer. Let's break down exactly how this solves the problem. The core issue is that computers prepare pages much, much faster than printers can produce them. So the OS solution is print spooling, which queues those translated, driver-ready pages in the background in exact order. The result? The physical printer just pulls that data off the spooler at its own comfortable mechanical pace. Your CPU is instantly freed up, and you can get right back to working on your next task without skipping a beat. So next time you tap a screen or click a mouse, will you think about the invisible chain of software translations making it happen? It is truly fascinating to realize that every seamless digital experience relies on this hidden army. From the application shaping your intent to the OS directing traffic, all the way down to those absolutely crucial device drivers acting as the ultimate translators. They're all working together in fractions of a second to turn your digital thoughts into physical reality. If millions of lines of code and dedicated driver translations are required just to print a single piece of paper, ask yourself, what other invisible armies of software are silently running the rest of our physical world? Thanks for joining me on this explainer, and stay curious.